So yesterday I told you what is intensive properties. So intensive properties where their values remains constant. Even if you, for suppose you take this is a parameter, this is a parameter. If you change this parameter, the potential has to be changed. If you change this parameter, the cell potential has to be changed. But this won't happen like that. Why? Because it's a intensive properties. Electrode potential and cell potential, they will remain constant even though if you change these things. Okay, so they will not depend on amount of material present or whatever. Okay, they will remain constant. Is that clear?
Yes, sir.
Yeah.
Yes.
So stoichiometric variation in electrochemical cell reaction. For suppose if you see here, okay, so this is the, for suppose if you see this one, okay, so this is the first half reaction, yes or no? So what's happening here? It is reducing, yes or no?
Yes, sir.
So here there is a aqueous metal, this aqueous metal receiving 2 electrons. When it, we know, so what is meaning of reduction? Gain of electrons. Here this 2 plus is gaining 2 electrons so that it is balancing the +2 charge so that it become A. You know, right, when +2 and when -2 will come? If you don't know, just quickly listen this. First, suppose if you take a normal ground state of an atom, okay, let's suppose take a sodium. Okay, let me take a sodium. Sodium number is 11. We know that. Okay, what is meaning of 11? It's an atomic number. That means there are 10 positive charges, 11 positive charges are there. Okay, so if you see here 4 plus 4, 8, 9, 10, 11. So that's in the nucleus. So this is the positive charge inside the nucleus. The same way, there are total 11 electrons that are present outside the nucleus. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so these all positive charges are neutralized by all these negative charges. Okay, so the net resultant charge on this atom is neutral. That means it's 0. But what's happening now? If you see here, this configuration, this is 2, 8, 1. That means one extra electron is present on the outermost shell, which is making this sodium unstable. So what does the sodium will do? It will release this 1 electron. So when it releases this 1 electron, now the sodium will have 2, 8. So that's a stable configuration. But as it is leaving 1 electron, so 1 electron is reduced here. Now there are 10 negative charges and 11 positive charges. So the net resultant charge is +1. So that's why the sodium, when it loses 1 electron, it will get Na+1. The same way, when 2 electrons are taken, you will be getting -2. If 1 electron is taken, you will get -1 charge. Why? Because number of electrons are more compared to the positive charge. So it is making -1 charge or -2 charge. For suppose you take the chlorine or fluorine, they are 2, 8, 7. That means total 17 positive charge and 17 negative charges there. But this is not a stable configuration. So the chlorine wants to gain 1 more electron, so it will become 2, 8, 8. At that time, the number of electrons are 18 and the number of protons are 17. So the net resultant charge is -1. So when it gains 1 electron, the chlorine will get Cl -1. Okay, so here the gain of electron or you are adding electron, that we called it as reduction. The losing of electron, it is called as oxidation. So the oxidation result in positive charge, the gaining of electron will result in minus charge. Clear?
Yes, sir.
Yes, sir.
So that's a very fundamental basic thing. So let's get back. So see here, so this aqueous metal ion receiving 2 electrons. So whatever the positive +2 charge is there, when it receives 2 electrons, now it will become neutral. Okay, so this is a reduction reaction. Okay, so the whatever the ion is there, it is reduced by the 2 electrons and it become a solid metallic form. Okay, so and the same thing, what's happening here? You are just, whatever this reaction is there, you are multiplying with a factor 2. So see here, this complete reaction is just multiplied with factor 2. So that's how 2A plus 2, 4E electrons. Instead of 2 electrons, now become 4 electrons. Instead of single A, now become 2A. Even though if you increase it or you multiplied or you doubled it, but still the amount of volt remains same. Can you observe that? The potential here remain unchanged despite you double the stoichiometric coefficient. So whatever the coefficient present here, you have doubled it. So A become 2A, 2E become 4E, A become 2A. But still, the potential remain unchanged. Is this clear? So I can say that potential or the cell potential, it is a intensive. So what is meaning of intensive? I said, so value remains constant regardless of physical parameter change. So here electrode potential doesn't change. Okay, so this is the proof you can see here. So whatever the before statement is there, I'm showing here the proof. Clear?
Yes, sir.
Yes, sir.
So the number of electrons that are transferring become double, the amount of reactants are double, the number of products are doubled, but the fundamental nature of the reaction, it remains the same. Okay, the cell potential remains the same. So notice this thing, it is an intensive property. Okay, so what happens now? First, suppose the same reaction, you do the reversing. Okay, on reversing the chemical equation, the effect on the E is as follows. First, suppose you see here, A, it is giving AN plus Ne minus. Can you tell me what is this reaction? Oxidation or reduction? You see here, this is a normal, but you are removing electrons from this solid state. So what do we say when we remove the electrons?
The oxidation, sir.
Yeah, so this is a oxidation reaction. The opposite happens here. So what's happening? So whatever the ionic state is there, you are giving the electrons and you are neutralizing the charge. So whatever the ionic is there, now it becomes the solid. So what do we call? What is this? Reduction reaction, right? Am I recording the class?
Yes, sir.
Okay. So see here. So what's happening here? Oxidation is happening. Here, reduction is happening. So what do we call here? If you see the potential here, it is a standard oxidation potential. What is SOP means? As
Standard.
it is oxidation is happening, so I'll call it as the standard oxidation potential. As the reduction is happening, I'll call it as the standard reduction potential. Remember, the voltage for the oxidation reaction, we call it as the standard oxidation potential. For the reduction, we call it as standard reduction potential. And if you see their values are just opposite. The signs are opposite. So remember, the standard reduction potential is equals to the magnitude, but opposite to the standard oxidation potential in terms of sign. Okay. Just remember this. So when you reverse the chemical equation, the sign will become opposite, but the magnitude remains same. Is this clear?
Sir.
Yes, sir.
So when you reverse an electrochemical of reaction, the sign of E naught changes. So remember this. So what's happening here? So the standard reduction potential is equals to the standard oxidation potential, but opposite sign. Okay. And remember, we are not changing any chemical species. The chemical species are same. Okay. So, but opposite in sign for same chemical species. Remember, here the chemicals are same. The reactants and the products are same here. Clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now try to answer this question.
Sir, option D.
It's okay. Tell me, even if it's wrong.
Sir, option
Right. Option?
A.
Okay. Shrikar is saying option A. What about the others?
So
Yeah, Banu.
I also think option A, sir.
Mandara?
I think B.
Okay. Mandara says B. What about you, Sharon?
No, sir, D. A.
Okay. What about you, Sharon? Sharon, are you there? Okay, see here, we know delta R G naught. What is this? This is nothing but the Gibbs free energy, yes or no?
Sir.
And we studied the
Yes.
Gibbs free energy should be negative for the reaction to happen spontaneously. It should be less than 0, yes or no? So the delta R G naught should be less than 0, or you can say the negative when it is a spontaneous reaction. Okay, if it is positive,
So I think B.
Sharon, your voice is breaking. Join again. Okay, so delta R G naught, if it is positive, then we need to supply the power from the outside. It will become non-spontaneous reaction. Yes or no? When we saw different types of cells, we saw one is showing the spontaneous reaction, the other one is non-spontaneous reaction. Okay, so remember the option here A is correct. Clear? Can I go next?
Yes, sir.
Okay.
Yes.
So now tell this, which of the following is incorrect? So we know galvanic cell where delta, the Gibbs free energy, it's less than 0. It's negative. And electrolytic cell, it is positive. So electrolytic cell, you need to supply the energy, whereas galvanic cell, it is a spontaneous reaction where you don't need to supply any energy. So tell me, what is the answer here?
Sir, option D.
Galvanic and electrolytic cells are reversed for each other. No, they are not reversed with each other. Wait.
So they are right.
Yeah. Sorry, they are reversed to each other. He's asking. Okay.
Incorrect.
Yeah, this is correct only. We saw it has to be supplied. Sorry, it is free. You don't need to supply any energy. Whereas here you need to supply energy. Here delta R G naught is less than 0, negative. Here it's positive. So both are just opposite. We also read that statement, yes or no?
Yes, sir.
The galvanic cell is just opposite to the electrolytic cell. Next
Yes.
one, electrode potential depends on the nature of the metal. Yes, of course.
Yes, sir.
Okay. It depends on, because some metals are reductional, very good at reducing. Some are very good at oxidizing. So if it is good at reducing, so there the electrode potential depends. Electrode potential and cell potential are intensive properties. Just we saw. Greater the reduction potential, greater will be tendency to get oxidized. No,
To
it's
reduce.
reduction. Okay. So option D is correct. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now see this one. So given, okay, here electric potential is given, the cell potential is given. Okay, minus 2.93, minus 0.44, minus 0.76, 0.34. So based on this, which of the following is the strongest reducing agent? So what's the answer? I told you if it is greater reducing agent, it will be having greater potential. Yes or no?
Yes, sir.
And we know the greater electric potential or electric cell, that will be equals to the positive charge. Yes or no? For Gibbs energy, it should be negative, but for electric potential, it should be positive. Yes or no?
Yes, sir.
So remember, greater the magnitude of reduction potential value, stronger the reducing nature. So tell me, what will be the answer now?
Copper.
Second.
Hmm?
A, sir.
Yeah.
C.
D, sir.
So first write down the order. First write down the order. So which one is least here? Minus 2.93 volt. Next, minus 0.76.
0.4.
And then minus 0.44. And then
0.34.
0.24.
0.34 volt. Okay. So this one is for, so minus 2.93. This is K plus, and this one Fe plus 2. This one Zn plus 2. I'll just write down. Just
That's
that.
opposite, right?
It's a copper.
Sir, 0.76 for Zn, right?
0. Okay. This is Zn. This is Fe. So I told you the more the positive value, the here it will be E naught is max in this. Here E naught is minimum because it's the least value minus 2.93. The greater the positive value, the greater the reductional potential is. Okay, so remember Gibbs energy should be negative, but the electric potential should be the positive. Okay, it should be greater than zero. It's just opposite to the Gibbs energy. Remember, electric potential is just opposite to Gibbs energy. Because Gibbs energy should be negative values, whereas the electric potential should be positive values in order to be having the maximum value. So from this, what is the answer?
So copper, sir. Copper, sir.
Yeah. So the answer is A. Clear? Any doubts?
No, sir.
No,
No,
sir.
sir.
Okay, now see this one. Mn plus 2 plus 2e minus is giving rise to Mn. Mn plus 2 is giving rise to Mn plus 3 plus e minus. Here the electric potential is also given minus 1.18 volt, minus 1.51 volt. Okay, so the possibility of the forward reaction is. So come on, tell me, what will be the answer? Try this. Try this. Once read the question and try this. I'll give you 2 minutes. If not, I'll explain. It's okay, just try. Even if it's wrong, just try. I'll give you an hint.
Sir,
So,
option D.
what is the answer?
The option D.
Okay, Shrikar says the answer is option D.
So I think B.
B.
Bombay.
Okay, Sharon says B. Shrikar says option D. What about the others? Mandana,
Sir, option D, sir.
option A.
D, sir.
D. Okay, Banu says the option is C. Mandana?
So I think B.
Wow. Okay. Okay, see here. What is given here? So Mn plus 2 plus 2e minus, it's giving rise to Mn. So can you tell me what is this reaction? Oxidation or reduction? See
Yeah.
what's happening.
Sir, oxidation, sir. Oh, sorry, reduction.
Why you guys are
Reduction.
confusing between oxidation and reduction? So remember, oxidation means you are removing the electrons. That means in the products, you will be seeing the electron is removed. In the reduction, you will be seeing in the reactant, you are adding the electrons. So the reactant side will show the adding of electrons. So see here, on my left side, you are adding the reaction. That means before the reaction happened, you are giving the electrons. That means you are reducing this compound. So here the reduction is happening. But if you see this compound, after the reaction, the electrons are removed. So for suppose A is there, after the reaction, it lost the electrons. That means this will be oxidation. For suppose if you take B, here you are adding the electrons before the reaction. So this is called the oxidation. Sorry, this is called the reduction. Don't confuse, please remember. Reduction means before the reaction, you are giving the electrons. You are adding the electrons to the compound. Whereas oxidation, after the reaction, the product is the product is formed by losing the electrons. So this is the reactant and it lost the electrons. So the electrons will be plus E after the reaction. So this will be oxidation. Is that clear? So here you are adding the electrons. Here after the product is formed, the electrons are liberated. That means here this is oxidation. So can you tell me this is a reduction reaction? The first one is reduction reaction.
Yes, sir.
Yes or no?
Yes.
So let me
Yes, sir.
here. Okay. So it's given like this. So Mn plus 2 plus 2e minus, it's giving rise to Mn. And the other one, Mn plus 2, it's giving rise to Mn plus 3 plus e minus. Okay. So remember, this is, you are adding the electrons before the reaction. That means you are adding electrons to this reactant. So this will be a reduction process. And you see here, this is the reactant. The reaction has happened, and after the reaction, it has liberated the electrons. So this will be oxidation. Oxidation means the giving of electrons or losing of electrons. Reduction means the addition of electrons. Okay, so this is reduction, and we know reduction will happen at where? At cathode or anode? Reduction will happen at cathode or anode?
Cathode.
Cathode. Okay. If you have a confusion between the cathode reduction or cathode oxidation, remember it is CR. CR means what? Just represent, remember like this, is a class representative. Okay. So we know every class will be having representative. So is a class representative. Class representative means cathode reduction. Remember like that. Okay. And AO, you can remember anode oxidation. Remember this. Okay. AO, anode oxidation. CR, class representative. If you want, I'll make a mnemonic and I'll tell you tomorrow in order to remember this. So remember, reduction is cathode, oxidation, it is anode. Okay, if you have any confusions, always try to make a mnemonic for that. Some kind of abbreviation for that. Is this clear?
Yes, sir.
Yes, sir. Yes.
And
Yes, sir.
remember, it is, the value is given here. It is E naught is equals to minus 1.18 V. And here E naught is given as minus 1.51 V. Okay, so we know the formula. This is the electric potential for the half reaction. This is the electric potential of half reaction of oxidation. Yes or no? And the total we studied yesterday. Okay, so E naught is equals to E naught at reduction at cathode plus E naught oxidation at anode. And please be careful with the order. Okay, so reduction at cathode, oxidation at anode, and it's plus plus. So E naught is equals to minus 1.18 V minus 1.151 V. If I add both, I'll be getting minus 2.69 V. So from this, I can conclude that E naught is equals to minus 2.69 V. Now see this one. So you got the E naught value. Okay. So now the possibility of the forward reaction, yes or no? So how does the possibility of the forward reaction happens? It depends on whether the reaction is spontaneous or non-spontaneous. If it is spontaneous, without any external source, the reaction will happen forward. The reaction will happen. That means the reaction is taking place. You can say the reaction is forward. If it is a non-spontaneous, until or unless you supply the external source of energy, the reaction will not happen. So non-spontaneous, supply external energy, external source, so the reaction takes place. If you don't provide the external source, the reaction doesn't take place. Here, so reaction takes place without any external source. Without any external source. So when does the spontaneous will happen? When the Gibbs energy is negative or E naught should be positive. Okay, it should be E naught should be positive or Gibbs energy should be negative. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Not very positive.
One second. Okay, so just remember this one. Delta R G naught. Let me write in another color. So for the reaction to be spontaneous, it should contain delta R G naught should be negative. or Gibbs or electric potential should be positive. It should be greater than 0. Now see here, what is the answer we got? Minus 2.694. So tell me, is this a positive or negative? E naught is negative or positive in this case?
Negative.
So negative means the reaction is spontaneous or?
Spontaneous.
Huh?
Non-spontaneous.
Spontaneous.
Banu,
Non-spontaneous.
see carefully. E naught should be greater than 0. Then only it will be spontaneous. That means it should be positive value. Or Gibbs energy should be negative value. And for non-spontaneous, the E naught should be less than 0 or delta R Z naught should be greater than 0. You understood? So now I got E naught in the negative value. That means it is a non-spontaneous reaction. And when it is a non-spontaneous reaction, until I supply the external source of energy, the reaction doesn't take place. It will be not a forward reaction. So the answer is no. So minus 2.69 V, yes or no? It's a no. I should keep this option as yes, and this should be no.
Yes, sir. Then it will be confusing.
Clear?
Yes, sir.
Is this clear?
Yes.
Sir.
Yes. Yes. Sir.
So see here, E naught positive, that will indicate it's a non-spontaneous, sorry, E naught is negative. That will indicate it's a non-spontaneous reaction. So reaction forward doesn't take place. So no forward reaction until I supply some external source of energy. So the option will be D. Mandara, is this clear for you?
Yes, sir.
What about Sharan, Banu, Shrikar?
Yes, sir.
Clear, sir.
Okay. So now try this. For the reduction of silver ion with copper metal, the standard cell potential was found to be plus 0.46, 25 degrees Celsius. The value of standard Gibbs energy will be. So now he is asking us to find out the Gibbs energy. So what are the informations are given and what we need to find out? Come on, try this. First, you need to know the reaction. Okay, at least I'll tell you the reaction. I don't know whether you guys can write or not. So the reduction of silver ions with copper metal. That means silver ion. I should take silver. So what is the silver ion? What is the charge on the silver ion? It's +1 or +2?
Plus, plus one, sir.
Yeah. So let me take Ag plus. And what about the copper?
Neutral, sir.
No. Normally, if it becomes a charge, if it becomes ionic state, it will be +2
So
or
plus two,
+1 or
sir.
+3.
Plus two.
+2, right? So remember, this will give rise to when it, you're seeing the reaction of silver ion. That means the copper is giving electrons to the silver ion so that the silver ion is getting reduced. Okay, so that means it will become Ag. But as the copper ion given the electrons, now the copper ion will become oxidized. So it will become ion. You understood this point? So here silver ion, it's getting the electrons. So it is becoming the neutral. And who is giving electrons? The copper. As the copper is losing the electrons, it should become the copper ion. And what will be the charge of this copper ion? It will be +2. And if you see here, try to balance this. You see here, the silver can only take 1 electron, but the copper can donate 2 electrons. That means I should keep 2 silver ions with a 1 copper. You understood this?
Yes, sir.
So it will
Yes,
form 2 Ag. So this is how you need to make a reaction. So make sure you should know for every atom what is the ionic state. What is the ionic state? +1, +2, -1, -2, -3. You should know that. That's a fundamental thing that you will be learning in class 11th. So please make sure whatever the important atoms are there, at least for them, you try to note down this. If you note down, then at least you will get this one. Okay, how to make the reaction. So now you got the reaction. So try to find out how many electrons are transferring from one compound to other compound, or how many electrons are involved for oxidation or reduction. So there you will be getting the value of N. With the value of N, you know the F value, you know the E naught value, you can find out the Gibbs energy. So try. Everyone will do this. Come on. I'll give you 3 minutes. Please try to do this.
Sir, is it A?
Okay,
So it is,
the answer is A.
yes, sir. Answer is yes, sir.
Okay. What about Sharon and Banu? Sorry, Sharon and Shrikar.
So 1 minute.
What value like 887?
Okay. Shrikar, what about you?
So just a second.
Okay.
Will it be in kilojoules or joules?
I don't know, sir.
Sir, something in A or B, sir. I got 89, but then
Okay, so we are all saying option A.
It's A, sir.
Okay, so let's see. Yeah, Banu.
There's option is on.
Okay. So is this clear how the reaction I wrote when he says the reduction of silver ion with copper metal? See, if you don't know how to write this, then you cannot solve this question. So make sure you understood this clearly. Any doubts in this
Yes, sir.
writing this?
No, sir.
so
Okay, fine. So now the thing is, I need to find out the n factor. N factor, what is n factor? Nothing but number of electrons transferred during the redox reaction. So transferred means from one element to the other element, or from one molecule to the other molecule. So here two electrons are moving from copper to silver. Okay. So here number of electrons, the value n will be 2. Clear?
sir.
So I know the formula delta G naught. So delta Z naught is equals to minus NFE naught. So let's see here. So delta Z naught, I need to find out. N is minus 2 into F is 96,500 and is given 0.46 V. So if I multiply this, I would be getting around minus 88,780 joules. Remember this. Okay. So I'll be getting 88,780 joules. So, but the answers are also given in the kilojoules. So try. So I know 1 kilo means 1000. So I could keep it like 88.780 kilojoules. So that would be around minus 89 kilojoules. So what's the answer?
And A.
It's a A. So clear? Any doubts?